Hey guys, it's Campbell. Today we're going to be talking about normal force. If you are unfamiliar with this, in mathematics and physics, the word normal means perpendicular. In calculus, you may sometimes be asked to find the normal line to, like, the tangent line. If you see this symbol, the T, or the upside down T, sometimes it might be written with a little 90-degree symbol in there. This means normal, or perpendicular. So the normal force just means the perpendicular force. It's called this because it's the force pushing against an object on a surface. You may recall Newton's third law of motion, that every force exerted on one object by another will be met with an equal and opposite force. So, for instance, you put your bottle of Dr. Pepper here on a table, and the Dr. Pepper obviously wants to fall downward because of gravity, right? It's weight. But the table still sits there. It doesn't crash through the table. And this is because as the Dr. Pepper has force moving downward, the table is exerting a force upward that is the same force. So to calculate the normal force acting on your bottle of Dr. Pepper, it should be relatively simple. On a flat table, and let's pretend this is flat, okay, it's a flat table, the normal force is simply equal and opposite to the weight of the bottle of Dr. Pepper. Remember that weight means the force. It's the force that gravity is applying on an object. Weight is generally measured in newtons. So let's say that your bottle of Dr. Pepper has a mass of 0.6 kilograms. You would multiply that by g, the gravitational constant of Earth, to find the weight of it. And g on Earth is approximately 9.8 meters per second squared. So the normal force will be the weight but opposite. So if you multiply 0.6 by 9.8, you'll find that the weight of this bottle is 5.88 newtons, which means that the normal force being exerted on the bottle is the opposite of that. So you could say negative 5.88 if you want down to be positive. You could say that the bottle has negative 5.88 newtons acting on it and the normal force is positive. It doesn't really matter. I'm going to ignore the negatives for this video, and we'll just say that we'll refer to all of our forces as the magnitude. Also, I want to just give a quick thank you to my friend Parsa. He helped with this video. He wrote a lot of these questions, so thank you, Parsa. Now let's say that we move over to the planet Mars, where the gravitational acceleration is 3.7 meters per second squared. What is the normal force acting on our bottle now? Well, this means that we have to multiply our mass times our new gravitational constant. And this means that the weight of our bottle is 2.22 newtons. And so of course this means that the normal force is going to be 2.22 newtons. Okay, so whatever. Normal force is super easy. It's just the opposite of the weight, right? Well, not always. We'll move back to Earth. This time we'll place our bottle of Dr. Pepper on an incline. In this case, gravity is still pulling directly down, but our normal force isn't going to be in the opposite direction of gravity. Remember, the normal force is going to be perpendicular to the surface the object is sitting on, which means our normal force is going to be acting this way. So to figure out our normal force, we'll go ahead and draw a force diagram. We have our bottle of Dr. Pepper's weight downward and our normal force. So we need to find out what this force is. Well, I would recommend shifting your frame of reference so that the normal force is directly up. In my opinion, it just kind of makes it easier to think about, so we'll go ahead and do that. Here's our bottle, Here's the normal force, here's the force acting in the opposite direction, and here is the weight due to gravity. So remember that the weight of our bottle of Dr. Pepper on Earth is 5.88 newtons. And in this case, we are shifting our frame of reference by the angle in the question, 30 degrees. Now right here, of course, we have a right triangle, and we want to find our adjacent force, because the adjacent force is going to give us the normal force, but opposite, right? So remember our trig rules. We know that cosine of, in this case the angle is 30 degrees, is equal to our adjacent over our hypotenuse, which is 5.88. So we can do some basic algebra, and we can find that the adjacent force is 5.88 times the cosine of 30, which also is going to give us our normal force, which means that the normal force is going to be approximately 5.09 newtons. Alright, now let's make it a little bit different. We'll imagine we've got a 2-liter bottle of Dr. Pepper, and we'll say that it has a mass of 2.2 kilograms. We'll start off by finding the weight of this bottle by, again, simply multiplying the mass by the gravitational acceleration of Earth, and that is going to give us 21.56 newtons. Now once again, let's go ahead and draw our force diagram where we want our normal force. This time I'm going to just start off by shifting our frame of reference, and we'll have our weight over here offset by 50 degrees, and this is going to be 21.56 newtons. I'll go ahead and give you guys a second. Go ahead and pause the video, and if you haven't already, solve for the normal force of this problem. So once again, we're going to multiply our weight by the cosine of our angle. In this case, it is 50 degrees, and this will give us our normal force, or at least the magnitude of our normal force, which is approximately 13.86 newtons. Alright, let's do one last problem here. In this one, we're going to imagine that the bottle is sitting on a flat surface, but you are pushing down and to the right at an angle of 45 degrees from the horizontal with a force of 30 newtons. Take a moment and try and find the normal force acting on this bottle. Feel free to pause the video. Now I'm going to go ahead and solve for that now. So I already know that the weight of the bottle is 21.56 newtons, and I know that I'm pushing down and to the right with a force of 30 newtons. Now to figure out the normal force, that is the total amount of force being exerted upward on the bottle by the table, has to be equal to the total amount of downward force. Now I'm applying a downward force because I'm pushing down and to the right, and the bottle already has a downward force because of gravitational acceleration. So what this means is I need to find this vector right here, and once again this is a right triangle, and then add it to this vector, which is the weight of the bottle. So this time, because the 45-degree angle is the opposite angle of our vector here, we're going to do 30 times the sine of 45, and that's going to give us approximately 21.21. Now we need to add that to 21.56 to give us 42.77 newtons, and that is the total downward force acting on this bottle. which means our normal force, which of course has to be equal since our bottle of Dr. Pepper is not crashing through the table and it is not levitating into the air. Our normal force has to be 42.77 newtons. And that about wraps it up for this video on normal force. I hope you guys found this helpful. If you did, please be sure to leave a like and consider subscribing for more help with your physics, homework, among other subjects. Check out some of my other videos on math and chemistry. Let me know in the comments anything that you guys would like to see, anything I didn't cover in this video that you would like to be covered. And I will see you guys next time. Bye.